Vegetation monitoring is a very important aspect of ecology and a great tool that can be used to help us protect the environment, as it allows us to understand how the biomass of a particular area is changing over time. Plots such as the one that I'll describe to you today, for example, could be used to help us understand what effects global climate change is having on flora in a particular area.
A skilled team is required to create the plots, each 1 hectare in size, and to collect the data. It is a very detailed process, and the team vegetation protocol runs through all the specifics. Censuses are conducted annually, and the rest of this video will provide a brief outline of the processes involved in setting up a vegetation plot. Here is a list of the essential equipment needed to establish a plot. 2 to 3 technicians are required to set up a plot, and this again involves several key steps, precision, and attention to detail. The baselines of the plot are established first and are 100 metres long. From there, small subplots are made using thinner string. Subplots make collecting data less chaotic, as areas are clearly marked. All stems with a diameter greater than 10 centimetres need to be measured, painted, and tagged within a plot. On the slide, you can see how field personnel are recommended to move when measuring stems.
The point of measurement on a stem is at 1.3 metres. However, sometimes problems arise, such as if the tree is uprooted or buttressed. The protocol gives detailed descriptions on what to do in such situations. For example, a tree that is leaning, the measurement must be taken on the inside of the lean, starting at the base of the tree. All such problem trees have a code that corresponds to the issue, and this must be marked off on the field form.
Sometimes, nature does not conform to our plans, and if the base of a tree is in the path of your line, then it must be determined whether it is to be included in the plot or not. In a situation like the one presented on the screen, the compass holder decides where the centre of the trunk is, and if the centre is within the plot, then it is included. This is usually only an issue with larger trees. Lianas and other vegetation are also marked, and all tagged stems are assigned an X and Y coordinate to make it easy to locate them in the future. Collection of specimens is done in a separate visit, and samples are sent to a herbarium for identification. All the data collected is then uploaded to the team data repository.
Recensus occurs annually in the same 4 to 5 week period of the dry season as the previous census. The main tasks that occur during the recensus is the identification, measurement, painting and tagging of new recruits, and the measuring of previously tagged stems. Seemingly dead trees should still be included in the census for the next 3 years, as they could re-sprout. Overall, the protocol is very detailed and prepares the reader for many situations that may arise in the field. Human error may be one weakness, as people collecting data might interpret situations in a different way, hereby potentially skewing the data. Other weaknesses could be environmental factors, such as extreme weather events destroying the plot, or even a large animal could destroy the plot as well. Unfortunately, there is no real way to prevent such things happening, especially in such an unpredictable environment. And nevertheless, the protocol is very thorough and useful.